Ma'am, can we check your presentation if it's working fine?
Yes, yes. Please wait for a moment. Are you able to see my presentation?
Yes, ma'am. Ma'am, you can try scrolling it down or changing the slide if
Yes,
it's
yes.
working fine. Yes, ma'am, it's working fine.
What? It's a
It's
total of
working.
22 slides.
Yes,
Okay.
ma'am, we can see everything. It's all okay. Yes.
Okay, okay, fine. When I have to start, Mano? Mano, are you listening me?
Ma'am, we are waiting for a while for all the participants to join in. There are roughly over 100 participants. So we'll start soon.
Okay. Okay, do let me know when you will start. Okay?
Sure, ma'am.
Yeah.
Hello, good evening, and welcome everyone. Technology Robotics Society, on the occasion of Winter School of AI and Robotics, in association with IEEE, feel immensely honored to invite Ms. Vijeta Sharma as our speaker at the guest lecture series going on. Ms. Sharma is currently pursuing her PhD from Banaras Hindu University on the topic of artificial intelligence and working as a software engineer for Applied Artificial Intelligence Group at Center for Development of Advanced Computing, CDSE, Pune. She has authored publications on malaria outbreak prediction models using machine learning and prediction of diabetes using artificial neural network approach. Her research interests are focused on cloud computing, parallel and distributed computing, and applied artificial intelligence. And today, she will be introducing us to the use of AI for intelligent video analytics. Now we hand over this session to Ms. Vijeta Sharma. Over to you, ma'am.
Excuse me, ma'am, you're muted.
Is it audible?
Yes, ma'am. Now
Yes.
you're.
Okay. So are you able to see my presentation? Is my presentation visible to you?
Yes, ma'am.
Okay. Shall I start?
Yeah, sure, ma'am. Go ahead.
All right. Welcome, students. I am Vijeta Sharma. As she has given my introduction already, I am working in CIDE and I am AI researcher. And I am fond of artificial intelligence, machine learning, and deep learning. And recently, I am working on the video processing. So I will give you the detail. It's not a brief introduction of the things, but I would like give what exactly video processing is and how exactly it is different from the image processing, right? So you must be aware of the things that video analytics has already been very popular for the surveillance data capture and some other applications like activity recognition also. So here I would like to present that what exactly intelligent video analytics is. Have you ever seen the CCTV cameras installed at public catering? In fact, on your colleges also, so many things, so many video cameras, CCTV cameras must have been installed. So what exactly they are doing? They are doing actually the video analytics, but not intelligent video analytics. All right. Now, as AI researchers, if it's our turn, means it's not our responsibility, but yes, it is our research area to make these CCTV cameras as an intelligent device so that it can do the video analytics intelligently. Every time camera feeds are storing at the server and someone has to look at this. If we have to capture some anomaly detection on or some different activities and even other things which we like, which is in our interest, that we have to capture at a certain points, then we have to we have to intelligently make our camera feeds so it can be give desired reports, desired alerts kind of thing. So here my topic is intelligent video analytics to make the video cameras, video feeds intelligent. Okay, so why we are understanding the video here, right? So most of the video understanding is a frame based, and the objective behind the video analytics are there may be different, maybe background detection, maybe scene based analysis, maybe video understanding. If any event is ongoing, our objective may be to identify what type of event is ongoing, all right? Or if we are capturing some Am I audible or visible?
Yes, ma'am.
Yes, ma'am.
I think it is stopped in between. All right.
Yes, ma'am. You were frozen for a while.
Oh yes, yes. Please, let me start. 1 second. Is it okay now?
Yes, ma'am. Your screen is visible.
Okay. Please do let me know when it is stopped, right? Because I'm seeing at my screen, so I'm not able to see when it's closed. Okay. So we are here at what exactly intelligent video analytics can do. It it can do the action recognition, video object segmentation, video classification means any object from the video we have to classify. Like if it is in moving scene and we have to classify tree versus vehicle. This objective should be the video classification, video spatiotemporal prediction, any anomaly detection, like if there is any unattended bag at the airport or bus stop, that all kind of activity comes under the intelligent video analytics. And now it's turn to know what exactly video data is. First of all, I would like, do you have understanding of image data? You must have worked on the image data, right? Image data is nothing but the array of numbers when we process it in as a digital image in the deep learning things. So if we talk about the video data, it is just a stack of images. Can you imagine it? So the way we process the image data, the somehow similar way is to process the video data also. Or we can say video is the collection of set of frames per second, and it is arranged in the spatiotemporal order. Now it's advanced techniques is to move from the image processing to video processing. If we just focus that image processing task is a classification of images, and where we take some one image as an input and we use any of the feature extraction process using the CNN or simple any of the CNN flavors like ResNet, LXNet and all, and classify those images based on the extracted features. Right here, what video classification we are doing, since video is the spatiotemporal data, means if any human is moving in the video or any object is moving in the video, we have to capture that location also, x-axis, y-axis, including z-axis also. So when we extract the frames from the video, individual frames, suppose there is a video clip of 5 seconds, then we cut the video of that video in a different images. You can imagine in a 5-second video there may be more than 1,000 images, means frames. And now what we will do, we will process the each image, means each frame. Then based upon the feature extraction, we will find out that what is happening in the images, and later on we aggregate it using some suppose 50 images we are aggregating to know if human is doing hand raise, if human is walking. So aggregation of image classification is a video classification technique. But yes, it is going also very resource hungry and going older, because new techniques, new deep learning networks has already been introduced for the video classification task. So doing the video image classification and aggregating the result of that is not a appropriate method of video classification. Okay, so till here, I would like to know, do you have any queries regarding what exactly video is? Okay, so I'll go to next slide.
No, ma'am, not.
Manu, do you can you ask someone that if they have any query regarding what exactly video is, then I'll explain. Otherwise, I'll move to my next section.
We have the questions open, chat box open for questions, but there are no questions right now.
Okay, then I'll move on, right?
Yeah.
Because students should have a clear understanding what exactly they are listening, they are capturing the things. So they should understand how image is different from the video and why video processing is different from the image processing. Anyway, its video classification is one step ahead from the image classification, because this is the spatiotemporal data, means at the particular time series things are displacement is ongoing, means xy coordinates is changing as per the time series. So if we can improve our actual video classification result using the temporal nature of video, it would be more accuracy than what we are doing with the image classification and aggregating the result. Okay. If we see that we have different deep learning networks like Lstm and RNN also, which do not use these aggregation methods. Instead, they use the forget network, and where they use previous frames in as a input and current frame as a again input, then they process and they give the output of actual video prediction. These are the techniques where now these days these are the latest deep learning methodologies for video classification and video data processing. But these are very bulky and very huge networks, and it's also difficult to train it on a simple machines. Even we say if we are training it on a GPU, then it's also take lots of time, and it's very powerful machine is required. Another thing is, if we try to understand the LSTM internal architecture in terms of where weights are updating, where number of arrays, number of layers and all things, LSTM is very complicated. So these till date, if LSTM is using as a research method for the video processing, it is also a complex things. So transformers are the new things which we are using for the video processing. Okay, later on I'll talk about this. But till date, so many research has been done on the LSTM, RNN, and combination of CNNs also. These are the most three successful networks of the deep learning, especially for the human action recognition. And for small applications, if we are which we are trying to, we can avoid this LSTM and RNN network. We can use the rolling average over predictions using the CNN. Means if we want to aggregate the prediction which is happened from the image using the CNN, just imagine of if we want to aggregate the 50 frames, and we do what happened in the last 50 frames. This can also be a one thing for in video processing. See, here you can see it's a serial video data processing, where we are processing the frame by frame. Frames are nothing but our images per second, we would say, and arranged in the specific order. Okay, so first frame we are processing over here, second frame till the end of frame where our clips end, and now aggregate all the things using the rolling average aggregation, and then we come to know what happening in the video, which is our output. Let's say action recognition. Then if we want to predict is walking happened in the in a video clip or not, then all the frames we have to process, we have to aggregate the output, then we can say yes, in the last 100, 200 or even 500 frames we saw that there is a human is moving. That pattern says like walking of human. And here, see, as I discussed, Lstm is very complex because it takes input from the previous output, and it takes current input also. So processing of all these network is very bulky, and sometimes it's complex for the programmer to even understand the internal architecture of this network. Okay. In short, if I say that what exactly video processing is, if our objective is to do intelligent video analytics from the camera feeds where cameras are installed in a particular place, let's say what it is exactly video data processing. So we have taken one image as an input, and we did uh, predictions using the CNN, and we have chosen the label for the largest corresponding probability. Suppose in the 50 frames there is a probability of hand raise or walking or sitting, then we can predict that yes, this video clip is belongs to the human sitting, human walking kind of, and loop over all the frames in the video. That's same things. If we have cut the video in a small images, then all the images we have to process. Okay, so each frame pass the frame through the CNN definitely, and classify frame individually. All right, and definitely we do the labeling things. Finally, we do the rolling average prediction. Thus, we can predict exactly what happened in the video and from which video it belongs to. I think we will take a question answer session at the end only, right? Now, here I would like to introduce you the different data sets which are available. You must have heard about the ImageNet for the largest image data set, on which so many CNN networks has been trained, and we definitely use it as our pre-trained network for the transfer learning and all. Different, and C for 10 is also cat versus dog. So many image data set definitely you people will get at the Kaggle also, and this UCI image library and all. But what are the video data sets available? There are very few less data sets available for the video research. Few of them are YouTube 8M, UCF, which is the human action data set, and HMDB, human motion data set. Activity data is again also human activity recognition. Kinetic is also released by the Google, which has the different pose of different actions of human as per the different categories. AVA is also human action data set, and so many other data set. But yes, with the compare of the image data set, video data set is very less, and that's why research is not at that peak. As we have already seen that image data set, image processing is a very huge success on the different networks, different competitions and all. Let's see. What are the different applications of video data processing? And now we know that intelligent video analysis, because this video data processing algorithms will be feeded at the servers attached with our CCTV. Okay, which we are saying that our cameras are intelligent, and we are doing the intelligent video analytics. As surveillance system, we use as a human activity recognition, LTDL, child activity monitoring. Suppose if nobody is there at home and child is alone, so we can monitor where child is going, what child is doing. Alarm will be generated to parents' mobile or parents' machines where it is configured. So this kind of activity we can do with intelligent video analytics. Safety and security at public gathering, right? And anomaly detection, like unattended luggage is there at the airport, or just suppose there's an terrorist attack. This is a very big application, but yes, it can be possible because of human activity recognition from the video data. any kind of application you people can think which you observe that it is required from the society. Charity ethic is one thing, but similar to other things like if doctor is coming in the clinic or not, teacher is coming at classroom or not, and that even officers are coming in the office at a particular meeting or not, you know, that kind of things where headcount is also part of intelligent video analytics. Yes, robotics application, autonomous car, and because the car, if we say that it needs, uh, if car is moving on the road scene understanding is the most applicable area where autonomous car required the intelligent vehicle analytics, right? We have to identify if there is any tree in front of the car, is there is any human in front of the car, then in the scene we have to identify. Yes, humanoid robot. Suppose you are making some for robot for the factory, then that robot should know that in the given environment, in the given factory room, what where the tools are there, and how to where to go, where not to go, and how to pick the luggage, and where logistics applications are also there, where humanoid robots are deployed to work in the place of human, where safety is at top. So in the most, so many factories are using humanoid robot to get the help. That kind of things are required intelligent video analytics. Now we will talk about yes, all the things are there, but where we should we can researchers can run their applications to start their applications for the video processing research, right? So I will introduce all of you with the Param Supercomputer series, indigenously developed by the CIDEC Pune, and yes, this is the India supercomputer. Apart from that, I will talk later about the detail in the next slide. And yeah, apart from that, it's auto ML video intelligence, where you students can start your video related research, at least small applications you can develop on that. And Microsoft Artificial Intelligence platform thing, where action recognition networks models are there, and you just feed your data, action recognition data, and you can use the pre-trained and inbuilt models over there for the human action recognition, right? Don't confuse with the K instead of C, because it's recognition in the MS one, right? Yeah, Python packages are, which it's not a complete packages. It's a basic packages. I just wanted you to know that it is very similar to the image processing. Don't be afraid of what video processing is difficult. Video processing requires lots of coding and packages. No, it's just one step ahead of image processing. But yes, it requires huge computation power, right? Because data is very large. So NumPy packages, Pandas packages, this all use in the video processing also, as well as Matplotlib. Keras having very good APIs and packages where it's inbuilt calling of functions for the action recognition, especially for using for the processing. TensorFlow is having lots of packages for the video processing things, skimage, OpenCV we use to cut the clips for the different frames. As we use in the image processing to save the model, same way we do. This slide is objective is just to explain you that video processing is similar to image processing. You can start video processing research if you have fundamental knowledge of image processing using all these fundamental packages. And yes, believe me, it is the thrust area of AI research, where we use video processing knowledge for the different video analytics. So many areas are there. Okay, as I already told that these application video processing is resource hungry, and huge computation power is required for the video data. And definitely we have to choose the good platform to start our research. Huge computation cost is there if we use Amazon and all, and AWS is having very huge computation cost. And capturing long context in video data is also a problem if we do video processing at the simple laptop or simple machines. Scalable video analytics is also we can do using the large high performance computing. Latest GPU configurations are there, which you can definitely use like your image processing task. And the GPU V100 and DGX machines, these all are properly scalable and configurable for the video data processing research. Yes, if we do the parallel processing, that we can get the full benefit of all these high performance computers if we make our program parallel computing. You must be aware of the exascale computer. Do you know if we are doing research on the intelligent video analytics, video processing things, then we are raising the need of exascale computing. We must be knowing that आवश्यकता आविष्कार की जननी है, right? So if we researchers are doing video processing, we are on high demand for the exascale computing, where a larger scale of video data can be processed, can be scaled up, can be processed in a very short time. And till now, we have in India, we have petascale power of supercomputers. So definitely, we researchers are in the step to build indigenous exascale computing, and we are also in the way to run our AI application, video processing applications on the exascale machines. This is screen, I believe this is the most your favorite screen of favorite slide of my presentation, because here you can see list of supercomputers which is developed by the CDEC. It's indigenous developed, and Param Shakti is on top of that. It is deployed in your university only, IIT Kharagpur, and we are very happy to see all of you are doing very good research on that. Next is Param Siddhi AI supercomputer that is especially designed for the AI application. This supercomputer is having GPU powers and all the libraries which is required for the AI, and visualization is also visualization software is also as per the AI requirement. Like every time we need Matplotlib and TensorBoard, and also all these AI related applications packages are fully loaded in the Param Siddhi. Next is the Param Shivai, which is deployed at the IIT BHU. And yes, there are also so many research are ongoing on the AI while running the parallel applications on IIT BHU Param Shivais. Param Brahma is deployed in the ISER Pune. This also supports the AI applications. And yes, if you want to, before submitting your job, you want to make the parallelize your computings and to see the result of your model at your end. So Param Shavak DL GPU is the supercomputing solution in a box where high accelerated deep learning video analytics applications can also run properly and at high speed. And yes, these supercomputers are under the national supercomputer missions of the India, and India is also progressing, and Param Siddhi ranked under the 500 supercomputers at the international level. So I'm so happy to tell you all that you can leverage the power of Param Siddhi to run your AI applications very well. Okay, now if you have any questions, so I would be happy to answer that.
Yes, ma'am. We have a few questions.
Please.
So first question was you, ma'am, you mentioned a few video processing research uh, names. Uh, we were just asking how are they different and what exactly do they provide?
Sorry, can you repeat your questions?
Yes, ma'am, you provided different platforms for video processing research, right?
Yes,
So
yes.
how are they different and what exactly do they do and which
Okay,
would you
let
say
me
is
come
the
on that
best one?
slide. Let me come on that slide. Video processing, research, different video processing. Right, this one now.
Yes, ma'am. Yes, ma'am. Yes.
Platform for video processing research. Okay, these are the platforms. I mean, these are the machines on Auto ML. Video intelligence is the cloud on yeah, Amazon and sorry on Google and Microsoft Artificial Intelligence. This is also cloud service. If you are asking like how we can use all these platforms, is this a question?
Yes, ma'am. So, what do these platforms provide? Like,
Yes,
do
yes,
they?
yes. Very, very nice question. Very nice. I was actually waiting for this question. Suppose if you want to run your AI application, not exactly the video processing, but yes, image processing also. If you want to run your applications, then Param Supercomputers has all the packages installed on this, like TensorFlow, Keras, sklearn. So they provide you easy configurable environment platform where directly you can deploy your directly you can put your submit your applications, submit your code to run the easily. Instead of this, what you will do, you will buy a machine at your end, you will install different software at your end, right?
Yes, ma'am.
If there will be any error like this package is missing, again you will install it. No, all these platforms are ready to use inbuilt softwares which exactly supports the AI research or are having here only. AutoML is also is nothing but a cloud service for specific video intelligence. Means all the libraries which is required from the video processing is already installed over there. Okay.
So, are they saving processing power and computation time? Type?
Yes, yes, these are all our supercomputers. You must be familiar with the Param supercomputer, right?
Yes, ma'am. I've heard about it, but I don't really know its use.
No, no, definitely you all will choose. So these all are supercomputer. Everything is whatever I have mentioned over here. They are on supercomputer, and these all three AutoML, Microsoft Artificial Intelligence, and Amazon Recognition. All these three are on the cloud-based supercomputers provided by the different providers, Microsoft, Amazon, and Google. And Param is our indigenously developed supercomputer.
Ma'am, so suppose if we want to do video processing, we will can we do it in like our normal computers or we have to have a supercomputer to help us?
Definitely, you will require supercomputer. Have you worked on the image processing task? Any image processing application?
Yes, ma'am. Very basics. We do not know in very great details, but some idea we have.
You are a first year student?
Yes, yes. We just started learning a bit of computer vision.
Okay, okay. So, have you understood how video processing is different from the image processing?
Yes, yes, ma'am.
Okay, then you must be knowing that if we require supercomputer for the image processing things. Suppose we have 1,000 classes. ImageNet, you must be familiar with that. ImageNet dataset.
No, ma'am.
Okay, so ImageNet dataset is the world's largest image dataset, which won lots of challenges and all. So AlexNet, GoogleNet, all these are the CNN networks which are properly trained to recognize the 1,000 object categories: cat, dog, trains, rails, all these things. To train the convolution neural network for those 1,000 classes, that researcher required high performance computing, supercomputing. So definitely for the video processing things, it is must to run the application of on supercomputer. Normal computer never support this. Cannot no. It
Okay,
will not
okay.
handle because processing network is very complex and huge, as well as data. So normal computing level supported.
Yes, ma'am.
Yeah.
And another question was, ma'am, you were mentioning many applications. So, video analytics current any application is in use, or are they future prospects?
Okay, you are talking about this slide.
Yeah, yeah.
All right, very nice. So this human activity recognition is already using for the. I should not reveal the exact project name on which we are working, but yes, human activity recognition for the road safety and people safety for the smart city under the smart city objective. We are using this, and this child activity monitoring. It's a someone from the India only they made this application, and safety and security is also head count. Do you know the head count application?
No, ma'am. Like, but
If
I
you are
can.
going in a public gathering, like in any Kumbh Mela kind of things, so how many people are entering? Okay, these kind of things can happen using the head count. Hmm? And anomaly detection. Suppose any luggage is there at the airport, and someone is coming, touching, and then nobody is coming at that luggage or something. So that kind of application requires intelligent video analytics and also robotics also. So what more you want to know in this application? Anything else you want to know about this application in the detail?
No, ma'am. I was just asking if they are in current use. I think there are plenty
Yes,
of
yes,
applications.
it's
Right?
all are in use. Human activity recognition is very on it's a very popular research area. Even in India, I'm talking about in Indian researchers. I am working on that field.
Okay, ma'am.
Yeah.
We have another question. So,
Yes, please.
Akshat is asking, in image processing, we have
Yes.
learned how to check the RGB values for each pixel and change them however we want. So,
Yes.
in video processing means to split it into a lot of frames and work on them. So,
Exactly.
are we using a for loop for that or something like that?
Yes, yes. My this slide talk about this. We have to use. He is using. He is asking like if image processing we are using RGB recognition, color recognition for that convolution loop. Same thing we have to do for the image processing or video processing also. He must be talking about the convolution layer, 3x3 RGB, right?
Yes, yes, okay.
Yes, the same thing we have to do for the video classification also. Is there any question on this thing? Because I'm highly interested to explain my this slide. Anybody interested?
Ma'am, we are sure interested. Ma'am, can you please go ahead and share some?
Very nice. Yeah, yeah. Actually, all these Param series of supercomputers, we are not exactly but as a team of CTEC, which we are developing the supercomputers that are at a high requirement for the artificial intelligence application. What happened previously, we were using the supercomputers only for the specific applications like weather forecasting and landsliding predictions, rainfall predictions, and glacier lake monitoring predictions. So all these type of applications were rule-based applications. I'm talking about 10 years ago when an application was glacier lake monitoring. Some camera were installed over there, and we were getting the sensor data. Every second sensor data we were getting, and we were processing it at real time. So that type of applications were running when we were having Param UR2. Okay, but now with the use of artificial intelligence for the natural language processing, we have a very large team for the natural language processing research, and we saw that how supercomputing can be used. This powerful machine can be used for the artificial intelligence application. And yes, and vice versa, we also observed that artificial intelligence is require huge data. So process of that huge data, big data means big data, we can leverage the power of supercomputers. So that was the phase when we coined the term convergence of artificial intelligence and supercomputing, high performance computing. So a year, almost 3 or 4 years ago, we started to port our applications, artificial intelligence applications, on the Param Shavak. It's a supercomputer solution in a box. Means if any small business required supercomputer, but they cannot afford it, so they buy that Param Shavak, and it was the surety that if any application runs on that Shavak machine, then definitely it will run on the supercomputer Siddhi or Shivai, Brahma, anyway. So that was the small solution where we were working for the AI, and later on we moved on the Param Shivai and Param Brahma, where we got lots of libraries which supports the AI applications. And first time we took the advantage of TensorFlow on a supercomputer, and we were so happy to run our application to Param Shivai, where and yes, one of the application of video processing, I'm also working on that using the Param Shivai, and Param Siddhi is specifically built for the AI applications. And Shakti, it is in your university. So this is having lots of AI applications, AI packages. Still, if you need any other packages which for as per your model, as per your coding, so there is a ticket system where you can generate the ticket and you will get the full packages of AI. Okay, so it's all supercomputers are building under the National Supercomputing Mission for the AI supercomputers in India. So India is going ahead in terms of developing AI supercomputer.
So these were newly installed in.
Actually, what happened? There was a National Supercomputing Mission is ongoing way back of 5 to 6 years way back. There is a mission for installing 73 supercomputers across the India, in which we have installed Shivai, Brahma, Siddhi, and Shakti. So we are in the pipeline to installing across the India, so that all the researchers can get the benefit of supercomputer and their specific region. Suppose you have Shakti and it is catering entire the West Bengal. All right.
Yeah.
All the institute which are the nearby IIT Kharagpur, they can also use the Param Shakti. So Shakti is catering the West Bengal region. Param Shivai is catering the UP region, kind of, so that all the students, all the researchers can get the benefit. So this is the.
So this is like one physical device, or is it cloud based only?
No. It just kept in your university only. It is physical. It's a huge machine. You people are in the first year. So definitely in the coming year, you will have a visit in a supercomputer lab. Your senior must be aware of all these things, and I am happy to see all of you as a fresher and having interest in AI. And it's good for all of you that one supercomputer is in your institute only. These are all our physical computers, big computers in a room. It is placed.
Okay.
Yes.
Actually, Akshat was asking a previous question, so he's following up on that right now. So he's asking, so in face recognition system, we break the video incoming into thousands of frames, and then we check on each of the images. So won't that be really slow? So how is it happening?
Have you seen this slide? That is why, to overcome that problem, to using CNN and performing image recognition task on each of the frame, it is a definitely slow process. That's why Lstm and RNN are introduced. But the problem of these networks are they are very bulky, and if there will be any error and all, it's difficult for the researcher to quickly solve it. It's yes. My answer is yes for your question. It's
No, ma'am. So when we are suppose we are using face recognition system in our laptop, that isn't very slow. So
yeah.
where is the
First
like?
thing, yeah, you are asking very practical questions. I've also gone through all these phases. Suppose you first of all you should start your research from the Google Colab. Hmm?
Yes,
Do you have any understanding of Google Colab?
yes, ma'am.